So this video is just going to give you a couple of more examples of the adjusted winner procedure that we learned in class. This procedure is meant as a way of dividing up a bunch of assets between two people or two parties. Okay, so in this case we have just three assets, a painting, a necklace, and a car. And two people, Bob and Carol, are trying to decide who gets what. Maybe this is an inheritance thing or something like that. So as we learned in class, the way it starts is both Bob and Carol each get 100 points that they are allowed to divvy up among the three items. So you see that that's shown. So Bob puts most of his points into the necklace, Carol puts most of her points into the car, but they put different numbers in all their spots. So this is a reflection of how much they value these three things, and it may be financial value, but it also may be sentimental value or just something they want for whatever reason. Okay. All right. So what happens next is we initially give each item to whoever gave it more points. So Bob gets the painting and the necklace. Carol gets the car. Now that's an initial allocation, but we will now adjust it. So what we want is we want both Bob and Carol to end up getting the same number of points. Right now Bob gets 73 points, right? 6 and 67. Carol's getting 61 points. Okay, so Bob is getting more points than Carol. If we stopped right now, this would not be equitable. So the definition of equitable is that everybody thinks they're getting the same sort of size of the pie. Now both Bob and Carol think they're getting more than 50%. Bob thinks he's getting 73 out of the 100, so 73%. Carol thinks she's getting 61. So they're both getting more than their fair share in their own eyes. But the amount beyond 50% that they're getting is different for both. So this would not be equitable yet. But we're going to make it equitable. We're going to adjust things now so that they have the same number of points. Okay, so right now Bob is considered the initial winner because he has more points. And we go to each of the items that Bob has and we figure out the point ratio. Sorry, my pen is acting a little funny here. But so we're going to figure out the point ratio, and that means you take, for each item, the points that Bob assigned divided by the points that Carol assigned. Now, we're only doing this for the things Bob is getting. Okay, so 6 divided by 5 is 1.2. So that's the point ratio for the painting. And for the necklace, it's 67 divided by 34, which is 1.97 or thereabouts. Okay. Now what we do is we want to move things from Bob to Carol in order to even things out. And we start with the lowest point ratio. So that would be the painting, right? 1.2 is the smallest of the smaller of the two. So the first thing we do to adjust is we move the painting from Bob to Carol. Okay, so now Carol has the painting, and so now Bob has 67 points only, and Carol has 66. Okay, so, and by the way, we were able to move the whole thing over, and Bob still has more points. If moving it over made Carol have more points, then we would not have done it, and we would have divvied up the painting. We would have had them share it in some way. But that didn't happen. We were able to move the whole painting from, we didn't have to share it. We moved the whole thing. Bob, instead of Bob having it, Carol has it. And Bob still has more points. He has one more point than Carol at this point. So now we actually do go to the second item on our list. We go up in point ratio, but of course there were only two, so this one's done. And now we go to this one, the 1.97. The necklace and the Carol, and the necklace. And so now, of course, moving the entire necklace over to Carol would obviously give Carol way more points. Carol would have 100 points and Bob would have 0. So we're not going to do that. That's too much, right? But in order to even this out, they're almost even, but not quite, we need to just give Carol a small share of the necklace. A small share of the necklace. Okay, so what percentage of the necklace should Carol get so that her points will go up by just enough and Bob's points will go down by just enough that they end up being equal? That's what we're looking for. Now in class I showed you the algebra way to do it. However, I've decided in this example to maybe streamline that a little bit, and I'm going to show you just a formula that is the same. It's basically the result of the algebra that I showed you in class. So it goes like this: the percentage of necklace that Carol will get, the thing we called X, is the following fraction. On the top, we put the difference between their points. So right now, Bob only has one more point than Carol. So that goes on top, the 1. And on the bottom, we add together the total amount of points that the necklace was worth for both Bob and Carol together. So 67 plus 34. So what's that? That's 101. 101. So that's it. So again, let me just repeat what I said there. And by the way, here's the full list of the adjusted winner procedure. And I'm talking about right here. So the X turns out to be, again, the difference in the points, the winner's points minus the loser's points. For us, that was just a 1, divided by the total points for the shared item by both parties. That was the 67 and the 34 added together. And that's it. That fraction is the answer. So for us, it was just 1 over 101. And so Carol actually gets just a tiny fraction of the necklace, 1/101th, 1/101st maybe is how you would say that, of the necklace. And so Bob gets the other 100 out of 101. He gets that percentage of the necklace. And you can leave them as fractions, you can turn them into percentages, however you want to think about it. Okay, so I'm going to erase all the lines around the necklace. And so Carol gets the painting and the car, but they're going to share the necklace. Bob is going to get this fraction of it, and Carol's going to get this fraction of it. Okay. And if we check the points, if I just redo the points totally, if you add up for Bob, so he's not getting the painting or the car, but he's getting almost the entire amount of the necklace. He's getting this fraction of the necklace. So if I take the 67 points that he thinks the necklace is worth and multiply it by that fraction, 100 over 101, I get that he's getting 66.3 points. And now for Carol, she is getting 5 plus 61 plus, and she's getting just a tiny share of the necklace, 1 over 101 times the 34 points that she thinks the necklace is worth. And I get exactly the same number, 66.3. Okay. So now they both believe they're getting 66.3 points worth of stuff. Yeah, so that's the answer. So just to sum up what everybody's going to get, Bob will get, again, just almost all, but not quite all of the necklace, and Carol gets a painting, car, and a tiny bit of the necklace. Now I know it's a little weird, and this is one of the cons for this procedure, is that one of the assets, one of the items, does eventually have, or unless things come out even without doing it, usually one item gets split or shared somehow, and that can be awkward. So having 1/101st of a necklace is kind of weird. And I'm sure in this case what would really happen in real life is Bob would just give Carol some amount of money that they can agree on to sort of take care of that, and then Bob just keeps the whole necklace. That would be the most sensible thing to do. Yeah, but at least one thing is you only have to share one item. All the rest of the items do go to one person or the other, so that's good. What else do I want to point out? It was equitable because both of them feel like they're getting 66.3 points worth of stuff. So in other words, because it was out of 100, 66.3% of the stuff. So it's definitely equitable. It is proportional. Proportional for two people just means everybody feels they're getting at least half, and we said they are because they're getting 66.3%. Each of them thinks that. And it's envy-free because if Bob thinks he's getting 66.3% of the worth, then he thinks Carol is getting, what, 33.7%. She doesn't think that, but he thinks that's what she's getting, right? That's the rest. That's what the things she's getting valued by his point system would only be 33.7. So he thinks he's getting more than her, so he's not envious of her. He would not want to switch with her. And the same with Carol. She thinks she's getting 66.3% of the stuff, and she thinks Bob is getting 33.7% of the stuff. So neither of them would switch with the other person. So it's envy-free. And this one is harder to see for sure, but it is Pareto optimal. Well, actually, it's not too hard in this case. Pareto optimal means two people. With two people, Pareto optimal means you can't make a change to what we've decided on that makes one person happier but doesn't make somebody else sadder or unhappy about it. And that's the case here, because clearly if we made Bob happier, that would only happen if we gave him something more. But that would have to be at the expense of Carol, right? We'd have to take something away from Carol, and then she would not be as happy. So and vice versa as well. So this is Pareto optimal. It's kind of a zero-sum game when there's two players. So Pareto optimal will be the situation if we've divvied everything up. If we've divvied everything up. Okay. So I will do one more example, the one that I was starting in class, and I'll just do this kind of quickly. So instead of objects that people are going to get, these are issues that two roommates have a conflict over, and they want to figure out who gets to decide how each conflict goes. Okay, so we have the 8 conflicts, the 8 issues, and they divvy up their 100 points. And so again, the first thing is that whoever gave the most points to an issue gets it. I'm skipping the tie for a second. Okay, so for the tie, it doesn't matter in the initial round when you're just divvying them up. It doesn't matter who gets the object or the issue in a tie. It'll be worked out in the rest of the procedure. So I mean, only because there's 4 here and 3 here, I'll give the alcohol issue to Mike, but we may switch that, or that may be the one that gets shared. That's all fine. Okay, so there we go. So we figure out how many points each got after this first stage. So 71, 81 points for Mike, and 42, 50, 55 points for Phil. All right, so Mike has more points. He is initially the winner. He's the initial winner. Phil is the initial loser. So we go to the 4 things that we gave to Mike, and we figure out the point ratio for each. So 50 divided by 25 is 2. Mike valued the party issue 2 times as much as Phil. Cleanliness, also 2. Alcohol, 15 over 15. This one is 1 because that was the tie. So a point ratio of 1 means they had the same number. And lights out, 10 divided by 2, that one's 5. Mike valued that 5 times as much as Phil. So the one that is the smallest is the alcohol one. All right, so the way this works is now we try to move the issue from the winner to the loser and then see how the points go. But if we did that, if we were to move this over to here, Mike's points would go down by 15, which would put us at 66. And Phil would go up by 15, so he would be at 70, right? So if we moved alcohol over to Phil, then Phil would have more. So we don't. We don't want to switch who the winner is. We want to just bring them to an equality here. So alcohol is just going to be the one that we share, that Mike and Phil share. All right, so oops, let me just erase that. This will be the one that we share. So we don't give it over. So actually there are no items that we completely give from Mike to Phil in this part of the procedure. We're already at the sharing part. Okay. So how much what percent of the alcohol issue should Phil get from Mike? Because initially we gave it to Mike. Now Mike has to share some of that has to go to Phil. So the percent of the alcohol issue that has to be given to Phil is and let me rewrite these 81 and 55 because we're not crossing them out. All right, so on the top goes the difference between the 2 points, which is 26, I think. 81 minus 55 is 26. And on the bottom is these two numbers added together, 15 and 15, so 30. So 26 thirtieths. 26 thirtieths is also reduced to 13 fifteenths. That's a reduced fraction, but also it's 0.8666666. So 86 slash, almost 87%. So that's how much of the alcohol issue has to go to Phil. Okay. All right. So he gets part of it. He gets 13 fifteenths. He gets most of it, in fact. Phil only keeps, I guess, 2 fifteenths, or the other, whatever, 13%. Okay. So what we can do at this point is just write down what everybody's getting. And here it is. So Mike gets the party issue, the cleanliness issue, the lights out issue, and 2 fifteenths of the alcohol issue. Phil gets the stereo issue, the smoking issue, the phone issue, the visitors issue, and 13 fifteenths of the alcohol issue. Okay, and then one more thing we can do is now just redo the points, because after we split alcohol in this way, what are the points? So now, if I just add up what everyone's getting, Mike is getting 50 points, 6 points, and 10 points, right? The 3 things that he's just getting outright, plus 2 fifteenths of the 15 points that he assigns to the alcohol. So 2 fifteenths times 15, which is actually 2. And so now he's getting 68 points. And if I do Phil, he gets 22, 20, 8, 5, and 13 fifteenths of the 15 points that he feels that issue is worth. So 13 fifteenths times 15. And sure enough, it comes to 68. So they're equal again. And that's just a check. They better come out equal. We made these fractions such that these points would come out equal. so that it would be equitable. Okay, so that's it. Yeah. So I hope that these two examples help clarify how this procedure works. We're going to learn another procedure in class that works for more than two people. I also hope that I've maybe simplified a little bit the way of getting the fraction part for the thing that the two parties are going to share. I hope I made that a little bit easier. So, okay.